All right, so let's import our classifier into our Google Notebook. So the first thing that we need to do is we need to create a variable called classifier, which will hold our classifier, and we can set it equal to sentence classifier, which is the function that we imported from Ernie. Now, in this function, we can pass in our model name, and this model name is just the name of the model that we want to import from Hugging Face. So the one that we want to use is the BERT-based uncase. So I'm going to click that. Now, if you want to read the documentation, feel free to do that, but I'm just going to copy this, go back to my notebook, or was it this one? Yep. Paste it here, and then I'm going to set the max length equal to 64, and 64 is just the cap of how many characters we're going to have in our data. And then here we want to pass in the labels number, which is 3 because we have 3 labels. So let's run this, and it's going to download this model. And while it downloads, we can load our dataset into a format that our classifier understands by writing this line of code. We can do classifier dot load dataset, and we can pass in our data frame that we created above, and we can set the validation split equal to 0.1. And this is just going to split our data into 10% validation and 90% training. So we're going to train on 90% of the data and test it on 10% of the data. Now we can run this, and it's going to load the data set very quickly because we only have 200 lines of code, or 200 rows of data. And when you fine tune a model, it's not necessary to have lots of data, but it's always nice to have lots of data. I just want to show you how you can create your own data set and apply it to a state-of-the-art natural language processing algorithm. So now that we've done that, we can fine tune our classifier. So we can do classifier dot fine tune, and then we can set the epochs to 7. Now, any number between 2 and 10 is a good number for the state-of-the-art natural language processing fine-tuning algorithms. So I'll be sure to stay in that range. Next, we'll set the learning rate equal to a very small number. So we'll do 2e minus 5, which is 0.00001, so 5 zeros, I think. And so we can run this, and you'll notice that we start training our classifier on our dataset that we created. So that's very exciting, and I think it's very cool. So yeah, I'm just going to let this run. I just want to make sure there's no errors, so I'll just wait for this to go. But you'll notice that once it starts going, it goes pretty quickly, especially if you set the runtime to GPU, which I did not do, but if I change it now, I will lose everything I did. But do make sure you change the runtime type to GPU if you want it to run faster. And you'll notice that it starts training, and we are training on CPU, so it's not going the fastest that it could be going. It might be worth it for me to... Okay. Yeah, so the numbers that we're looking at right now is the loss and the accuracy. Now, we want the loss to go down, and we want the accuracy to go up. Now, if the loss is a low number, then we can say that we've found the most optimal set of weights for our data set and our model, and we can say that we've created a good predictive model. So we do want this to go down, and we want this to go up. Right now, we're at 50%. And it is training very slow, which is unfortunate, so I will stop this, and I will change the runtime type. So let's say yes, stop that, change runtime type, GPU, and so now we're running on a GPU, but I can terminate this. Okay, so we do need to run all of this again because we changed the runtime. And yeah, so that's running, that's good. We shuffle our data set, shuffled, download our data set, load, and then fine tune. And I hope this time it's a lot faster because we changed our runtime to GPU, and that just gives us access to a free GPU. So I guess we'll see right now. And yep, I'll just wait. Maybe we can look at some data science jokes. As you can see, by late next month, you'll have over 4 dozen husbands. that's linear regression. Yep. Your theory is wrong. Oh, damn, outlier right here. So, ooh, outlier, because it's not on the line. And once you find this line, you found your best predictive model, and you have a very low loss function. So this is what a low loss function looks like. And another thing is because, well, there's this outlier here, so there is a big error, and so the loss is probably still a bit higher than it should be. So it'd be best to remove that outlier. Okay. I built a system that predicts the exact question you're going to ask with 85 precision. That's us. Cool. Okay. I think that's enough. Okay. So here you can see it's training, and it's still very slow. I don't know why. It's unfortunate. But I'll let this train, and I'll see you guys once it's done. All right, awesome. So I just pressed stop, and I stopped it at 84% training accuracy. So that's very good. And you'll notice that the validation loss and the loss both go down. So that's also very good. And our validation accuracy, which is testing our model on unseen data points, we're getting a 73%, which is pretty good, especially for sentiment analysis. It's pretty good, but there is room for improvement. But this is where I'll stop for now. Now, you can feel free to continue training this, and you can restart where you last finished by just running this code block, and it just continues training the neural network that's already been trained. So that's also a very nice feature. So I can just, if I want to train for one more epoch, I can do that, and it just trains it for one more epoch. Now, I don't want to do that, so I'll stop it here. And so now that I've done that, we can start testing it on new data points, or we can predict on data that it has yet to see. So in order to do that, we do need to import NumPy. So we can do import NumPy as NP. And then let's create this text variable. And in this text variable, which is the text that we want to predict, we can do buy Bitcoin now with caps, ... It is a great investment. Okay, so that's the text we want to predict. We can do a variable called probabilities, and we can set it equal to classifier.predict1 text. Okay, and then you'll notice once we do that, we have our output here, and each number here represents our label. So we have 27% that it's bearish, 8% that it's neutral, and 64% that it's positive. So for us, in order to squish this into something that we can read, we can do classes. So we'll create a list called classes. And in this list, we will have bearish in the same order that we had for our labels. We'll have bearish, neutral, bullish. And then we can do print classes. And then inside classes, we will do np.argmax. So we'll take the max argument, and that max argument is going to represent the index of the highest probability. And so if we do this, it's going to print out. All right, I'll just copy, paste. Then we get our output, and our output is bullish. And then we can change this to sell Bitcoin now. It is terrible. I hate it. We can test that. Bearish. Beautiful. So we've built a predictive model that can predict sentiment on a tweet, whether a tweet is bullish, bearish, or neutral. Now, this is a very powerful algorithm, and this is what quantitative hedge funds in New York and Wall Street use all the time to have an understanding and have an automated sense of what's going on in the market. So I hope you guys find this interesting. Now, in the next video, we are going to save our model and download it onto our local system. So I'll see you in the next video, and I hope you guys are excited.